This paper was presented at the JCT Traffic Signal Symposium 2024, thanks to our media partner Highways News, and sponsored by AGD Systems, Four-Way Consulting, Traffic Group Signals, Smart Micro UK, TRL Software, PTV Group, Census Networks, and Starling Technologies.
Comments at lunchtime saying you don't look anywhere near old enough to have started work that long ago would be much appreciated. So what's AI? What's it all about? I think for those of you who can see that curve up there, the reason why it's so popular at the moment is there's a little dot near the top of it called generative AI. And that's a Gartner hype curve for this year. And the reason people are talking about it so much is the biggest tech companies in the world are now pushing it to everyone. So the hype is there. Where we sit is over on the right-hand side, there's something called intelligent applications, which has had its hype. And what we're doing now is delivering and coming back up the delivery curve for intelligent applications. Oh, and by the way, we have a patent that was approved this year, which is a development from the last time I spoke, because COVID affected the patent office, so it took 5 years. So where did our interest in this start? Now, my thanks here go to, I think it's Margaret still here somewhere? I can't see. Margaret Bell and a professor who works for me, Professor Lee McCluskey, were two of the leading academics on a project that looked at the use of AI in Europe. And we characterised at the time autonomic road transport systems. And from that, we identified that there was a number of systems in use, one of which is Scoot. So whether you know it or not, a lot of the people in this room have been using AI for quite a long time. And I'll go on to later why that is a AI system. But that's not the only place that AI is used. I think anyone who's looking online at the moment at people trying to venture into space on the first commercial space work will realise space is a difficult place to work in. And AI has been used in space for a very long time, purely and simply because you can't micromanage a spacecraft from Earth. So you have to give it intelligence to work. And one example of that, Deep Space One, that goes a very long way from Earth. So you have to give it a goal and understand what it is to achieve. Now, that went out in 1999. Very few people noticed. Where people do notice is when AI achieves something that people find surprising. When I was growing up, it was AI being used in chess games and able to beat chess masters. Where it became to popular attention, 2011, IBM's Watson computer won a very popular game show in America called Jeopardy. So hence the reason why in most game shows, you're not allowed to bring your phone in, because if you could use your phone, you'd beat everyone. So what is AI? I think the way I tend to look at this is people have intelligent behaviours. And that list on the left-hand side is really some of the things that we do, that we think about and understand and do consciously. There's also a few on there that we do unconsciously, which we describe as our autonomic behaviour. And if any of you have driven here, driving is a combination of thinking behaviour and autonomic behaviour. There's a lot of it you do without thinking, which is why it takes a while to learn it. But the modern conception of AI is all about trying to emulate them behaviours using computer techniques. So if you take the list on the left, that is what people do and what is regarded as intelligence. If you take the list on the right, Those are some of the many AI techniques that can be used to emulate that. And I think the way I would understand it is the skill here is picking the right technique to solve the right problem. And as an analogy, I was thinking about an analogy beforehand. A good analogy is if you're into horses, you would know that horses, big topic, but you wouldn't use a dressage horse to enter the Grand National. That would be inappropriate. And in the same way here, you have to have a knowledge of each of the techniques to understand that you get the right technique to solve the right problem. So where we've come at it is to try and pick a technique that was widely used prior to us starting, but used in a different context. So the technique we've used is one that's used in space. The Mars rover, when it was used, had some really good planning and scheduling software that allowed it to know where it was. It allowed it to know what was around it through detection, but it also had self-awareness. Because from Earth, what you would do is tell it to do things. You know, go up a hill, collect some samples, and deal with stuff on the way. And what we tried to do is take that, if you like, extraterrestrial concept and apply it to Earth or terra firma. But we've done it in a similar way. So I was really interested in Andy's topaz discussion and the way things are defined, because I think the thing as an industry we need to do is get really good at defining what it is traffic control is. What's available to you, how we describe it, how we describe all the data objects. Because when you start to bring in machines, you need to be precise. You know, we do use structured and unstructured data, but being precise. So I really welcome those efforts on standardisation. But we also need to describe what you can and can't do. And we've captured that, and this is part of our patent, is we've captured a way of describing in planning and scheduling language traffic control, and described it in such a way as it can solve problems really quickly. So this is the bit where I'll try, but I think you're welcome to come and grab us between now and the end of the conference and subsequently. So I'll try and describe how it works. And the reason I can do this is we purposely went out and patented it because we think it's an important breakthrough. And thankfully, the UK Patent Office regarded it as an important breakthrough in the state of the art. But we want to share it both with local authorities, but across the industry, because we think it addresses a problem which is non-recurrent congestion or the other effects of traffic moving around or the balance between people, buses and cars that wasn't being captured very well with existing systems. And we've used this approach to try and address it. So you're very welcome to copy, plagiarise this. However, you'd need to apply for a licence from us because we like to licence both all the industry players, but also either sell it directly and indirectly to clients. So the way it works, in very straightforward terms, is we start off capturing what's gone on. So you would say, I used an example with one of the clients the other day, we looked at the morning peak from that morning, captured the way the system was working, and then turned that data into a fixed time plan. Generally speaking, that fixed time plan is worse than Scoot. Occasionally it's better, but most of the time it's worse. And it doesn't achieve the goal anywhere near as good. We then take that and run it through a planning and scheduling engine and a solution engine to within 2 minutes solving a goal and coming up with either some new timings, or we have a function where we could take all of the timings you have available in your traffic control system and pick the one that's best for that moment. But we do that within a couple of minutes. And that's the really difficult bit, because for years, traffic engineers have come up with new solutions, but it's really difficult to come up with them very quickly, because when you get an incident, you need to respond almost straight away. So the aim of this was to be able to come up with something new straight away and be able to implement it. So that's kind of the way it works. I tell you the bit that most people have struggled with is to define a goal in terms that a machine can understand. So what is it you're doing as traffic engineers? Try writing that out and explaining it to a computer. That's the thing that people have struggled with, but in the places where we've done it, it's actually worked really well. So I'm happy to answer loads more questions on that if people want to ask. Now, when we presented a couple of years ago, I think our finishing slide was, this is what it's going to be like. Now, this system architecture, which is a data lakehouse in the middle, which deals with structured data, and as I say, I really welcome the moves towards modernising the structure of traffic data, but also deals with unstructured data, because that's what data lakehouses do. And within that sits our AI, and sits the ability to come up with new things, which we can then push to UTC, UTMC systems, and we take stuff in. So that's kind of the way it works. That's the way the architecture works. And Marc will hopefully explain to everyone some of the benefits we've had from using it.
Thank you, Keith. It's going to run through 3 case studies just to show how it's been used and, as Keith said, some of the benefits that come from that. The first one was with working with Kirklees Council. They had a Muse concert in June 2023. It was going to be the largest attended event at the John Smith Stadium in Huddersfield. Sadly, Huddersfield Town Football Club doesn't have quite the same draw. But it did mean that and it set as well, it was going to happen on a Tuesday rather than a Saturday, which is where previous events have tended to happen. So the first thing we needed to do was actually try and create a view of what that traffic pattern was going to look like. And to do that, we took the existing data from a Green Day concert that had happened on a Saturday. We looked at a typical Tuesday type traffic flows, merged those two together with the predicted attendance for the concert to generate an understanding of the flows as we'd see it, a prediction of doing that. What this graph is showing actually is the prediction, the estimate in the very thick red line, and the actual that was recorded on the day in the green line. What we did find, which is useful for future planning, is that people arrived a little bit later for the concert, possibly because of the workday, but left the concert a little bit quicker. With that knowledge, we then need to look at the data. So we worked with Swarco to get data from their UTC that we could then model with these predictions, put that into the AI engine that Keith's been talking about to generate new traffic signal plans that we could then implement prior to and post the concert. This is all done on the Wakefield Road, which is the eastern corridor, one of the key routes accessing that stadium itself. Too far, probably. No. So some of the benefits, what came from that? Prior to the concert, we improved the traffic, the flow by about 8%. This is trying to combine the people leaving work at the time on Tuesday and people arriving for the concert. Post the concert, we improved it by 68%. These two photographs are not before and after. It was actually taken within moments of each other by the client. One is the Leeds Road going north, that's the image at the bottom. The other is the Wakefield Road, which we'd worked on at the top. And there was roughly the same volume of traffic using both at the time. One of the key highlights from it, or 2 commendations we got from that, is Councillor commended the traffic signal team for the traffic plan without knowing that anything had been done. And a taxi driver taking a colleague to the stadium said, I'm going to have to drop you off about a mile away. That's normally the closest I can get. He was able to take him all the way to the stadium, drop him off, and pick him up from the stadium afterwards. And he said it was unprecedented. The second case study is with Hull City Council. We've been looking at signal plans for them. They had a particular problem around congestion in the city. The city itself is dissected by a river, which causes problems for them as well. Here we worked with data from Unix to look particularly at corridors. These are sort of scoop regions in there. The one we're looking at is the bottom left-hand one. The key goal here was to look at improving bus reliability. It's a very congested corridor, had lots of problems with it, and we're looking for a new solution to try and help solve some of the problems along that corridor. We also used DFT bus open data by some data service to understand where the buses are being held up. So we're actually collecting that data, storing it historically, and being able to analyse that to try and find the pinch points that we could then translate back into what we might do with the traffic signal plans. Feeding all that data in to the system. The sort of results we're going to find is that Monday to Thursday, we could make an improvement on average around about 16-17% in the AM peaks. This was applied to the AM peak and the PM peak. On the Friday, though, the system just works happily at the moment, so it wasn't actually worth implementing plans on the Friday. It should be noted that there was a slight increase in the volume of traffic through the corridor as well at the time. In the PM peak, we made about a 7% improvement, but there was a 40% increase in the traffic. And that was due to the A63, a parallel road, having roadworks on it and forcing traffic onto this Anlaby Road in Hull. And the third one, very briefly, because we've got a red light already, there's a key bus corridor running through east and west in the town, in the city. There's bridge works needed to take place. These are going to take place in the summer of this year. What they'd found previously is there's massive delays to the buses of up to an hour being caused by the disruption of this. So they asked us to put into place plans, traffic signal plans, which were generated through the AI system, to try and alleviate those sort of pressures on the buses when this planned bridge closure was going to take place. About 2 weeks after the plans were created, a routine inspection forced the actual closure of the bridge. So the plans were put in place, operated, diversions happened, and the delays were reduced to about 15 minutes each. Keith?
I'll be very quick because I think we're over time. One of the next steps from this is the original thought behind developing this system was that at some point the traffic industry will move the same way as the railway industry, which is to move from trackside signalling to in-vehicle signalling. So our thought here was, at some point, traffic control will move from roadside to in-vehicle, and we can do all this in-vehicle, which then means you can do a completely different way of traffic control. Now, that's not going to happen tomorrow. However, what we're trying to do at the moment is encourage the first step, which is to make it transparent to the vehicle users what's happening to the traffic lights ahead of them, which is to try and encourage the widespread use of GLOSA, time to green, and other things, because if you can make that move, then the possibilities of doing things differently open up. So anyone would like to go with us on that journey, very much like to talk to you. We're also conscious that we don't have the full answer here. Anyone who's a regular to this conference will know there's a lot of good techniques in traffic control. And what we've done is try to create something that fills a bit of a gap. But actually, the best solution will be the ones that combine all of them. So you pick the right technique at the right time to solve the right problem, in the same way as I described previously about picking the right AI technique. So we don't have any particular, preference about licensing to people or collaborating or working, because we think it's something that could be useful to everyone. However, there's a few things that we have at the moment which should be of particular interest if you're a local authority in the north of England, is Innovate UK have taken a punt on us, and my thanks to Innovate UK for giving us a project called Connecting the North. But if you're a local authority in the north of England, your prime area for helping us demonstrate this technology. And we're currently lining up which authorities we're demonstrating which techniques. So if there's anyone we haven't talked to, I'd love to talk to you now. We've been trying to stretch the definition of the north a bit, but I'd like to get at least quite a few of them in the north of England. There's also other opportunities, I think. The main aim of the Innovate UK project is to take it from a very good, promising technology with good results to something that's mainstream and do it quickly. So actually we're hoping to get help from Transport for the North to do the business case to make it mainstream funding through traffic signal funding, the ITMF or something like that if ever it happens, and also the other things like City Regional Sustainable Transport Plan. So we're trying to plan ahead to work out how you do all this quickly, because the thing that's very noticeable, being the CEO of a company working in the AI space, is it moves quickly and stuff move on very quickly. And if as an industry we want to adopt it, we need to be equally as agile and equally as quick at moving things forward. Because we're competing with the energy industry, the water industry, or particularly when our form of AI, we're competing with games, computer games, because they use planning and scheduling as well. So if as an industry we want to attract more use of AI, we've got to be forward thinking to say, right, we're starting now and we need to push budgets forward out into the future, because that's how we can attract the talent, by saying that this is going to transform it. Okay, that's us. Sorry we took so long.
That's okay. We are still ahead of schedule, you'll be pleased to know. I will go to the floor for questions shortly, but I actually have a question myself. AI is everywhere. Everyone's talking about it. And some people, we had the National Security Advisor yesterday talking about security. Some people are quite worried about AI and what that means. In your view, what can we do as a community to help the adoption of AI within the traffic industry?
I think things like this help, that the more people who can be comfortable at explaining what it is and what all the techniques are and which ones should be used in which circumstance, the less likely we are to fall foul of unconsciously blundering into a cybersecurity problem. And I think there's a lot of companies in the sector who really have got that talent and that knowledge. But I think as an industry, we've got to start talking specifics, because, generative AI can be used as a general thing to do certain things, although my word of caution on it is most generative AI techniques, the way they work is you tell it something, it copies it, and it repeats it. So if you're going to use it, be prepared for that to be repeated somewhere else. I think a lot of companies have ring-fenced it so that doesn't happen, which is a really good approach, but the government committing and local authorities committing to saying, over the next 10 years, we're going to do something like this, you can then start thinking through what staff do we need, what budgets do we need, and how do we take it forward. And it was really nice today to see data centres recognised as being critical infrastructure, because without data centres, none of this stuff exists.
Thank you. Any further questions from anyone? We have one from Chris up there. As far away from the microphone as you possibly could be, Chris, but it's on its way.
Hi, Chris Cattell, TRL. So you need to have a scoot system in the first place in order to work with yourselves, in order to source that data?
The simple answer is no, but our preference at the moment, because I think Scoot is currently the most widespread advanced traffic control system that's available, it's a really good thing to have that, because that provides a lot of good information as well as a good traffic control technique. So our preference is to have that, but ultimately no is the answer.
Okay. Follow-up question to that then. In respect of consuming data from the respective UTC system, what information are you making available back to the manufacturers, the originators of those systems?
We would like to make as much information as possible back to you to help understand the transition between the two techniques and help to feed that back to all of the manufacturers we work with. I think the reason being is this is a journey where we all can learn as manufacturers from this process, because ultimately now there's a number of different techniques being introduced, and the handover between the techniques and the decision-making process of how you choose one or the other at any given time, I think it's got to be a collaborative effort. And that's why on our Innovate UK project, we're wanting to collaborate with all the main manufacturers and suppliers, because I think that process would be greatly enhanced by having a collaborative approach. I hope that answers your question. And
Just about. Thank you.
okay.
Thank you, Chris. Anyone else? Well, I think we're good. Thank you both. That was very, very interesting.